Hi, welcome to our math. Today I'm doing a series of videos on lines and systems of equations, and in this video specifically we are going to graph a system of equations. Alright, so our first one, 4x minus 6y equals 24, there are two ways of graphing it. The first way is with the intercepts. I say, hey, what happens if x is 0? If x is 0, then negative 6y equals 24, and if I divide by negative 6, y is equal to negative 4. Well, what happens if y is 0? Well, if y is 0, then 4x equals 24, which is x is equal to 6. 1, 2, 3, 4, 5, 6. When I have a problem like this, I like to kind of look at my slope. 4 over 6 is going to be 2/3, and I sometimes fill in a few extra slope bits. You don't have to. I find it's nice when graphing to have all of the points of the grids because one of those will be the solution. Okay, if you don't like graphing the intercepts, you're looking at that going, no thank you. You also have the option of taking 4x minus 6y equals 24 and solving it for y. Subtract 4x from both sides. Negative 6y equals negative 4x plus 24. Then divide by a negative 6. Be really careful when you divide by a negative 6. Negative 6 divided by negative 6 is 1. Negative 4 divided by negative 6, we take out a negative 2 and get 2/3 x. Positive divided by a negative, 24 divided by 6, negative 4. Suddenly, we realize that this and this are the same equation, which means there's an infinite number of solutions. It means that these are the same line. Because they're the same line, the lines are dependent on each other. A lot of times when you're writing this answer on a computer homework system, they will have the answer x and y such that y equals 2/3 x minus 4. Curly brackets means this is the set of answers. This xy tells you what variables you're looking for, and then this is just your y equals mx plus b. A lot of times when you're doing it on paper, the words same line are just fine. The last word I'm going to give this is consistent. Consistent means that there's a solution. If it's consistent, there is one or more solutions. If there is no solutions, it's inconsistent. All right, so for my second system, let's see. Plus 1, that's my y-intercept. Notice in this case my slope is 0.75. Well, I don't want to graph a decimal, so let's just turn this into 3/4. So 3 up, 4 over, 3 up, 4 over. I'm also, again, going to do negative 3 over negative 4. I like backtracking my slopes. Negative 3 over negative 4, negative 3 over negative 4. I'm going to get out a ruler and connect the dots and have my first line graphed. Okay, my second one is negative 1. Now my slope is 1/2, 1 over 2, 1 over 2. I'm moving away from the line. That's bad. So, again, if my slope is 1 over 2, I'm going to do negative 1 over negative 2, 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 negative, it's all the way down there. It's very, very end. You can see in this example especially that if this had been done sloppily, you'd only done those 3 and you had gotten a little bit lower, you could very easily have thought that this was the solution because it's easy, especially without a ruler, to kind of bend your line down a little bit, and you might have pulled that as your answer when the solution is really negative 8, 1, 2, 3, 4, negative 5. Let's check. 3/4 of negative 8 is negative 6 plus 1 is negative 5. 1/2 of negative 8 is negative 4 minus 1 is negative 5. It checks out. This is consistent because there's an answer, so consistent. It's also, the lines are independent because they are two distinct independent lines. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!